Okay, so we just did a really quick check on Mathematica. So we put in our points. 1, 4, 2, 0, 3, 3, 4, 3. And then we did a fit. So what this equation in Mathematica is just saying is find the best fit to this collection of points, which is called A. We're just going to use variables 1 and x. And what do you think that is limiting us to?
It's just two variables, or even just one variable. It's the line.
It's a line, yeah. So we have a c and a d times x, and then we're using the variable x, and it tells us that the best fit is 2.5 plus 1.62 times 10 to the minus 16th x,
So which is 0.
right? Which is 0. So, and then when we look at, let me make this bigger. When we look at, is that on screen?
Yep.
All right, so when we look at the points, actually it's kind of interesting to see why this is a horizontal line. It's certainly not obvious that it's a horizontal line is the best fit. Do you have any thoughts on why it might be horizontal?
I mean, if you look at 2, you've got one's 2 bigger than 2, one's 2 less than 2, and then 2 that are 1 more than 2. So if you move it up by a half, you're gonna get 2.5 less, 1.5 more than 1/2 and 1/2.
Okay. Yeah, that's nice. And I wanted to, I pulled up a different Mathematica notebook. How do I shrink this notebook? Because we had previously done this project. And what were we looking at here?
This is the change in temperature. But we weren't fitting a line to the data, we were fitting a parabola to the data.
Okay, how did you remember this was the parabola?
Because in the original one, this was all really pale like this. But in the parabola one, we saw that it dipped and then was rising and was just getting slightly above what it was 100 years ago.
Very good. So this fitting idea, one of the examples that we looked is what the changes in temperature were in the U.S. in the last 100 years. And yeah, there were areas. This is the fit using a quadratic, and it shows that the temperature is increasing the most. Like the parabola is the steepest, kind of in the southern United States. But when we did a best fit line, we found sort of different warming trends. In fact, in the southern United States, that line was actually kind of flat, like we just found here. So it tells you that you can use different fitting algorithms to determine lines and stuff and fits. And what do you think you learned from that?
I think it's how to best represent the data. Like represent it in a more accurate way, and you might not see things that you would otherwise miss, I guess. Okay.
Yeah, well, a best fit line is going to help us when we think that the data is probably linear. And it's not clear what temperature changes might be. We saw different things here. But yeah, we'll talk about that more. But it's fun that you're learning the actual techniques now. Yeah, very good.